The next energy system we want to look at sounds ridiculously simple, and it's amazing that it's not been used before. But nonetheless, here we are with what is called cogeneration, which is ranked at 50 with 3.97 gigatons of potential for reducing CO2 emissions by 2050 and $279.3 billion in net cost, with a net savings over the 30-year operation time period is $567 billion. So what is cogeneration? It turns out that the traditional systems that are working just to produce power, provide electricity, and or the just boiler systems which are driven by fuel, typically fossil fuel, waste a lot of the heat, just like the example used always, the internal combustion engine, which wastes almost 2/3 or 3/4 of its energy as waste, which is going out of the tailpipe system, right? So they operate typically at 50% efficiency, and coal and nuclear are estimated to be functioning at about 34% efficiency, which is ridiculously low. So the cogeneration systems, typically as combined heat and power systems, actually capture that waste heat and then provide heat to buildings, and especially in Scandinavian countries like Sweden and Denmark, the large part of the year they need the municipal level heating for various office buildings and universities and shared public spaces and so on. So obviously they work much better in that sense, and the efficiency is argued to be 75% by this US Energy Department's website. The examples from I should put the website here, also from the Energy Department of the US. It is showing that you have a fuel, let's say fossil fuel or even solars or wind energy driven turbine, which is generating electricity that's going to buildings, facilities, or to the utility grid. And the idea is to recover that exhaust heat and then use to heat the water, produce steam or hot water, and then provide the cooling and heating, instead of bringing in electricity and using the electricity to do the lighting in the house and then separately drive a heating system within the house, where obviously the electricity generation itself is inefficient, and then within the house you are using electricity to produce heat as well as to run other utilities, including light and air conditioning, refrigerators, etc. Right? The more complicated system would boil the water with the fossil fuel and run the steam turbine to generate electricity, but also capture the heat to provide cooling or heating. So obviously in a country like India, such systems require to be focusing more on cooling, and very few places would actually need heat other than the far northern states during the winter season, and so on. But the idea is really simple, and other estimates of such combined cogeneration systems argue that if you look at the coal-fired power plants or boilers heating oil or water, waste enormous amount of energy. This one is not losing so much, but you look at this gray arrow, gray pipeline here, energy loss is upwards of 70-80% depending on how it's done, and then electricity here is going to light and then heat, either through a boiler system or electrical heaters, space heaters, and so on and so forth. Whereas the combined cogeneration using natural gas, for example, would reduce the energy loss here combined to this thick line here, for example, by a lot. And with a coal-fired power plant, more than half the energy input is wasted. Cogeneration reduces the primary energy demand by 36%, and the efficiencies shown here, separate power and heat capacity, total efficiencies at about 55%, with this happening at under 35%, and this is making up for the low efficiency by having a much higher efficiency. Whereas in a cogeneration system here, this website argues the efficiency can be as high as 87%. Of course, we have switched from coal to natural gas here, which would automatically up the efficiency as well in terms of energy per kilogram of fossil fuel burned in this case. Right? So obviously seems like a no-brainer, and in fact in Sweden, I think in Denmark, they have been running such combined heat and power systems for more than a century. So the book says, in our analysis, cogeneration refers to on-site CHP, combined heat and power, from natural gas in commercial, industrial and transportation sectors. Phasing out coal is almost required and imperative now. There is no way you can continue to burn coal for too much longer. In 2014, industrial coal generation using natural gas comprised approximately 3.2% of global power generation and 1.7% of heat generation. If adoption grows to 5.4% of power and 3.3% of heat by 2050, 4 gigatons of carbon dioxide emissions can be avoided. At an average installation cost of $1,851 per kilowatt, total installation cost would be $279 billion over 30 years of operation. By replacing the grid-based electricity and on-site heat generation with more efficient and less costly technology, the growth in cogeneration could produce operational savings of $567 billion over 30 years and lifetime savings of $1.7 trillion compared to business as usual, which typically is coal. So even if you change that contrast to another business as usual system, the savings and net benefits over lifetime are pretty massive. So that is very attractive. Also, the reduced CO2 is not mentioned here, but in the first slide we did see that it has about 4 gigatons of reduced CO2. For a country like India, which is hot, where heating is not a big concern, obviously cogeneration has to think of cooling systems. Okay, so that gives you an opportunity to think more about how that would work.